Let us look what gel permeation chromatography is. Gel permeation chromatography basically belongs to a category of size exclusion chromatography. The basic mechanism is the separation based on the size of the particles. This chromatography is also called as gel filtration chromatography. The nature of solvent and usually organic polymers are generally analyzed by this technique. As a technique, SEC was first developed in 1955 by Lathe and Ruthven. This technique was first investigated by J.C. Moore in 1964 and was also commercialized in the same year by Waters Corporation. Polymers can be characterized by a variety of definitions for molecular weight, including the number average molecular weight, the weight average molecular weight, the size average molecular weight, or the viscosity molecular weight. GPC allows for the determination of dispersity as well as viscosity molecular weight, and based on other data, all of the above properties can be determined using gel filtration chromatography. Now, my friend Christine will explain in depth about the mechanism of gel filtration chromatography.
Thank you, Paul. Now let's see the mechanism of gel filtration chromatography. The separation process in gel permeation chromatography is built on the radius of gyration of the particles that are to be separated. Porous beads packed in column are used for separation. The tinier the volume of particle, the easier it can enter the pores and longer they can stay there. The longer the time spent by these particles in the pores, and thus will elute last. Another feature that should be focused is the size of particle. If the particle in focus is too large, it will not get into the pores, and if the particles are too small, they may be preserved completely. Unpreserved particles are eluted with free vol that is usually at the outer periphery of the particles, VO, while the particles that are submerged fully are eluted with the solvent's volume that are kept in the pores, VI. The overall volume can be depicted by the resulting equation, in which Vg is the gel's volume and V T is the total volume. As it can be depicted from the above discussion, there is a specific range that can be separated by the specific column, thus the packing having pores of specific size should be selected according to the weight of the molecules that we are studying and size of the particles that are to be separated. Thus, the selection of pore size is key in doing gel permeation chromatography. One of the suggestions is that if there is a range of particle sizes in the polymer, then multiple columns are to be used to completely analyze the system.
Gel permeation chromatography is almost similar to liquid chromatography. Just like in liquid chromatography, samples in gel permeation chromatography are also first dissolved in solvent, but in this case the nature of solvent is specifically organic, and after the filtration process it is injected into the column.
The separation process basically takes place inside the column. A pump is used to make sure that the eluent is supplied in the column in constant manner. A detector is a must, as most of the naked eye is not enough to see the analytes. In some cases, multiple detectors are used to obtain results of high quality. It generally increases the accuracy of the process. The material required and the apparatus is discussed below. 1. Gel. Gel serves the purpose of stationary phase in gel permeation chromatography. Pore size of the gel is the most crucial part, and it must be controlled very carefully so that it can be applied to a given separation. It is generally advised that the agents that are responsible for the formation of gel are non-ionic. Some of the novel examples are H, W20, H, W40, agarose gel, LH20, PL gel, styrogel.
2. Column. Gel is used as the medium that is to be used to fill the column and is used for gel permeation chromatography with a microporous packing material.
3. Eluent. The eluent, which is the mobile phase of gel permeation chromatography, is generally a solvent for the polymer whose analysis is to be performed. It should have a good solvation ability, should allow high detector response coming from the polymer, and should wet the packing surface. Some of the most common eluents widely available are tetrahydrofuran, THF, O-dichlorobenzene, trichlorobenzene, M-cresol, O-chlorophenol.
4. Pump. Two types of pump are generally available for continuous and consistent delivery of fairly minute liquid quantities, and they are piston pumps and peristaltic pumps.
5. Detector. In GPC, the detector is used to determine the concentration of polymer on the eluent solver. Although, there is a wide range of detectors are available in the market, but they can be generalized in two major categories. Concentration-sensitive detectors, that is, UV absorption, differential refractometer, D.R.I. or refractive index, R.I. detectors. Molecular weight-sensitive detectors, that is, low-angle light scattering detectors, LALs, and multi-angle light scattering detectors, MALs. The graph that shows the distributions is called a chromatogram.
The chromatogram that is generated as a result is shown in the figure below. Advantages. Gel permeation chromatography is widely adopted because it has a large number of advantages. Some of them are discussed below. 1. Unlike other techniques, JPC offers well-defined separation time. 2. JPC is quite famous for its narrow bands. 3. Lower analyte losses due to minimal chemical or physical interaction with the column. 4. Comparatively, JPC offers a more convenient and less hectic method of determination of molecular weights of polymers. 5. It is very easy to investigate the properties of any polymer using JPC. 6. The processes used in the past were quite hectic and time-taking. The procedures were laborious, but using JPC it has been made possible to quickly determine the molecular weights and distributions of different polymer samples.
Disadvantages. As there are two sides of every coin, similarly there are some disadvantages of the gel-permeable chromatography. Some of them are given below. 1. Limited number of peaks resolution within short period of time. 2. Limitation of difference of molecular weight, as GPC requires at least 10% variation in molecular weight for a good peak resolution. 3. Before the use of instruments, performing a filtration is a must to avoid contamination due to dust and other particles that could ruin the columns and detectors. Applications. Due to immense range of applications, gel permeation chromatography is widely adopted around the globe. Some of its novel applications are: 1. Determination of relative molecular weight of samples of the polymer in focus. 2. Molecular weight distribution analysis. 3. Measurement of molecular volume and shape function, defined by dynamic viscosity. 4. Accuracy of almost ±5% can be achieved in the determination molecular weight distribution.
Hey Christine, shall we see the gel filtration process live?
Yes. Come, let's go to the lab.
Gel permeation chromatography, or GPC, is a separation method used to estimate the molecular weight distribution of polymers. The GPC has three main components. First, the pump is used to push the polymer solution and solvent, THF or tetrahydrofuran, into the machine. The second component, the columns, is used to separate the polymers depending on their molecular weight as they are pushed through the instrument. Porous beads, typically either polystyrene or glass, are usually used to separate the polymers within the columns, causing larger polymer molecules to flow through quicker. Smaller polymer molecules are caught up in the beads and diffuse more slowly. Finally, the UV detector is used to measure what and how many particles are diffused at a certain time, creating the distribution graph in the software. The UV detector observes the UV absorption of the polymer, which is proportional to the polymer concentration. Other detectors, such as differential refractive index and light scattering detectors, can be used. To analyze your polymer sample, first dissolve the polymer with THF. Once dissolved, pull the solution into a syringe. Then filter the solution to get rid of any particles that may clog the columns. Once filtered, use a 25 micrometer syringe to draw up 20 micrometers of the solution. Pump the syringe several times to eliminate any air bubbles. Next, put the syringe into the injection point. Click on the injection button in the top left corner in the software and enter in all parameters, including the name of your sample. Click on the injection button in the software and wait for instructions. Once the instructions appear, slowly depress the syringe to inject the sample. Then turn the knob to the right and wait 5 seconds. After 5 seconds, turn the knob back to the left. Carefully remove the syringe. It will usually take 30 minutes to complete the analysis of your polymer, and a graph will be shown at the bottom of the screen. Your graph will show a peak that describes the molecular weight distribution of your polymer. By comparing the running time with the standard provided, one can determine the number and weight average molecular weight along with the PDI or polydispersive index. Once completed, the sample will be saved within the software and can be recalled in the list provided under the Find Data button. Once your test is finished, clean the syringe by pumping pure THF through it several times. Calibration should be performed when needed. This consists of analyzing standard polystyrenes with several molecular weights.